Hi. Today the main topic is the B tree. Last video I just talked about what is the B tree and what is the history or context of the B tree came from. And now what we're gonna trying to do is how we trying to make a B tree. Let's say you wanna put some kind of random values of it. Example, 10, 30, 25, 7, 6, and 4, let's say. And to make a B tree, there is a thing you have to consider, which is the max key length. Max key length in the node. So max keys in node. So let's say we're just gonna put 2 here. Let's say 3 here. And now we just trying to insert this 10 on the root of here. Since we have no root in right now, we just have to create a new node of here. Let's say this is our root. Let's just put 10, 30, and 20. 10, 30, and 20. To select the primary key or the middle key is that you just have to select the middle part of here. But the thing is that the 30 is actually the last index. The 20 has to be middle of here. So if you're trying to make a B tree, you have to short it. We have to short the keys in the node. So our node is gonna be like this. And our primary key is gonna be 20. We just encountered that this node have maximum keys, which is 3. And we have to make a B tree of there. Not a B tree, we just make a parent node of here. And we select the which key gonna be parent. So our primary key is 20. Our median index is 20. We put this 20 on the parent node. So it's gonna be like this. And 30. And that's very simple, right? But now let's put 5, 7, 6. 5. So it's just simple like binary tree. When trying to insert some kind of value in the binary tree, the value that is smaller than the target nodes go to the left side of here, and if it's bigger, you go right side. And it is really valid in the B tree. You go 5, 5 is smaller than 20, and you go left of here, and now you now insert in this node. So 5 is gonna be here. Now next is 7. The 7 is next to the 5, so you insert the 7 value in here. Now we just encountered that this node is already had maximum keys up here. What we did the same thing in the 20 node. We make the 7 as a parent node, which because this is primary key. And let's go here. And when we're going to look at this tree, you might think something's weird is gonna be here. The 7 and 20, they are pointing at the same 10 value. My question is, why don't we merge this node and make this pointer into 1 rather than 2 over here? So that's kind of characteristic of the B tree. You insert the 7 inside the existing parent node. So the 5, 10, 30 is going to look like this. Since 5 is smaller than 7, it's okay. And 10 is bigger than 7, also 10 is smaller than 20. So this is also right, and 30 is bigger than 20. So that is how you make some kind of B tree. Um, but the hard thing I also encountered while making a B tree from the scratch was um, the right node, right pointer or left pointer. If you're trying to make some kind of B tree using your code or JavaScript or whatever, there's no kind of um, there's no kind of pointer out there. There's no kind of right node and left. There's no right left variable. So to try to explain those kind of B tree in data structure, this node have 7 and 20 kids, and there are children, which is node that has 5, and that has node that has 10, and node that has 30. So this is kind of data structure when trying to make this B tree into code. And I know you're also kind of confused because you don't know which one is the right node and left node. But it's very simple. Let's say you only insert the 6. You find which element is bigger than 6. It's 7, right? So 6 is gonna be go here. This part. So 6 is gonna go to 0 index, and 0 index is node 5. And also, let's say 20. Let's say 21. Since there is no the value that is smaller than 21, you go the last index of this key, which is 0, 1, 2. 0, 1, 2. And you insert this 21 into this part. And this is really simple. So you just have to figure out the index or the element that is bigger than or smaller than the target value, and you just have to insert it based on this index. And my kind of recommendation is don't try to make it like this. Make it, rather than making a plain like node like this, let's put some kind of this, I don't know what to say up here, but let's say some kind of edge, I don't know, but this is more comfortable than this part, because you can just use make a pointer based on this, and make a pointer based on this, like this. And so that is how you really design or B tree. B tree insertion is really simple, and you just have to search for the value that is smaller or greater than the target value, and you just have to go traverse into last node. What do you mean last node? Last node is gonna be the node that has no children over there. So you push the new key in the node that doesn't have a children. So that's kind of like how B tree it works. You don't put the value on the root of here. You always put the value inside the last step of this B tree. So this is it. Have a nice day. See you next time. Bye bye.